Hey guys, welcome back. We're in the shop again. As I film this, it's the very end of August. Actually, the kids are going back to school tomorrow. It's been a while since I gave you some updates on the Carbon Cub project, and that's because there hasn't been a lot of updates because summertime, we did a lot of traveling, vacation, summer camp, things like that. Out flying quite a bit this year, more than usual. So I just didn't have time to work on it. But like I said, kids are going back to school tomorrow. It's getting to be fall in a few weeks, so back to work. I've got a few things updated, and I thought I'd do a quick walk around and show you what we've done since last time. So I think where I left off is the frame up of the fuselage was mostly done. I had built the motor box. I had started to mock up the canister tunnel to support the mufflers and lay everything out. So since then, I get started back on it again. The engine's off. The canister tunnel has been finished, and as I probably mentioned the concept, I built this removable tunnel so you can take this out through the door and you can see the underside. With the mounts, I have to fuel proof the inside of that, which is not super critical, but I like doing that before I put it back in. So again, as a reminder, the deal is that the canisters will mount in here, and then I can insert this through the door, which you can see is wide open now, right on in here, and it slides into these tabs on the back of the firewall, and then just a couple of screws at the bottom on this former, which I'm calling like the dashboard or instrument panel former, to attach it. Then they'll be lined up with the inlets right here below the engine, so fit the engine and then hook up the pipes with the couplers. Their front exit, so the stingers, the down pipes will be right here, and there's going to be an opening in the bottom of the sheeting in the front of the plane, so I'll hook up nicely. So that's all set. I finished working on the cabin area. I did some extra reinforcements, so one of the things you'll probably notice, and for other guys who are building this kit that's different, up here, the vertical dowels at the front of on the windshield, front of the cabin here, I use carbon instead of a piece of dowel. You can use either. It's a nice straight piece that's not that long, so it's easy to use carbon. I had another carbon diagonal here. This is not called for. I did this for extra strength, particularly because I want to make a real functioning door and not cheat and leave the structure in place. So I did the scary thing, actually just yesterday, over the weekend, and actually cut out the structure here in the door. So the hinge door is going to be here, some piano hinges, door will open up, the window opens up like a real Cub. So you get this nice big open area, but now what happens is there's nothing supporting this the upper long run where it connects to the firewall other than the windshield, right? So this is triangulated, but put some forces on this. I could imagine this whole area twisting. So I added this piece down here to triangulate this to this piece. This diagonal helps to locate the upper part of the firewall so it's not pulling and stressing this joint. So they're all tied together. That comes down, tie these together. And you're also going to have these scale diagonals, the ones that connect to, on the wheel plane, it would be the top of the motor mount cage, ties it to the top of the cabin. So these are going to be installed. Now the sheeting goes on the top of here, so I'm going to have to make a template to make cutouts and install this. And I'm going to epoxy these things in really good because they're going to actually will be structural, help take some of that load. So that's all getting laid out. You can see I also started to sheet the cabin. Let me zoom out. I started to apply the sheeting to the cabin, which is all laser cut and interlocking. This goes together really nice. You can see on both sides, I painted the inside of the cabin all black. That's all in place, these pieces. Then you got some pieces in the front. Up front, they don't line up. Everything up to the dashboard line is perfect. Here, when I tried to dry fit them all, they don't quite line up perfectly. Might be because of how I changed the firewall to have this vertical so I could set the thrust line with the motor box, but I'm not sure. Up here, where the piece that will go here lines up with the the top cover is a little bit off. There's a bit of a gap, so I'm gonna have to adjust that. And I'm also gonna have to figure out how to clamp all that sheeting in and hold it. But anyway, I'm not too worried about that. That's more work to be done, but we will get to it. In the back, you can see the tails in place. I haven't started working on the elevators yet. That's the next project. But what I have done is started to lay out all the wiring. So since we're going with a bigger engine, and Badan says that it balances with a 120, I'm going with the 150. And he had all his electronics up in the roof of the cabin, which I've now opened up to look scale. To balance out more weight up front, I want to move some weight to the back. So I'm doing a few things. Number one is the rudder servo. Is going to go right there. Actually, it already is right there. Right, so I've mounted the rudder servo in the back, underneath where the elevators connect. And that's going to be a pull, so there'll just be a short little cable, short pull cables out to make it look scale. But it's mounted back here, and we'll have the horn. What I'm going to do is actually make an access panel right here that has the slots for the pull, but it's a panel that you can just undo to be able to get in there for maintenance. So put all that in the back. I also am putting all of the electronics behind the cabin. So on the real Carbon Cub, there's an option you can get for an extended baggage compartment, and there's a door on the side that opens up for this extended baggage area. So what I did is I took a look at some pictures and actually made the door. So I made the extended baggage compartment door, which kind of has this interesting shape. Pops down. There's a couple latches on the real thing. I'm just going to use heavy-duty magnets to close it. So again, some piano hinge, put a latch. You'll have this door. And in here, where the baggage compartment would be, I made this plate to mount all the electronics, and I'm starting to lay out all the wiring. So a little bit different, since this is the biggest plane I've ever run, and it's going to have, if I did the count right, 1, 2, 3... 9. Am I doing that right? Yeah, I believe we're going to end up with 9 Futaba A703, which are 900-ounce servos. Their Futaba brushless tend to be a little bit more efficient than some other brands like Savix and MKS, but they're still thirsty. They still pull a lot of juice. And actually, they warn you if you use an extension more than 1 meter long to include glitch buster caps as buffers. They give you these capacities and you have buffers, and they actually suggest you put them right at the servo at the end of long extensions. So I actually made all the extensions and wired up here. Here's where the elevator servos are going to plug in, and I actually wired in these caps right at the servo at the end of these extensions, because these things are like 4 or 5 feet long, believe it or not. Same thing for the rudder. I also started installing lights, which is from the Unilight system from Austria. These things are great. You can see them in broad daylight. I'll give you a demo in just a second. So all that wiring, and you can see all the wiring goes into the wiring tunnel that I installed. Runs up front and up to our electronics layout, where since we've got a lot of heavy-duty servos and it's the biggest plane I've ever done, I'm going to try something new for extra redundancy and finally try out one of these Futaba power hubs. So the DLPH2, which stands for dual link power hub, that gives you 2 batteries and 2 receivers and will automatically switch between the receivers if one of them goes bad. Also does automatic battery switching. Personally, I've never found that. I've never been convinced that's super critical. It actually senses the voltage and just switches between the highest one. I would actually rather they just be both connected all the time so they're draining evenly, but see, I haven't used one of these before, so we'll try it out. Maybe I'll be proven wrong, because I know that there's a lot of guys, including many sponsored pilots, that love these things. We'll try that out. So that's all set up. I've got 2 receivers, one mounted right here with the antennas vertical and pointing lengthwise down the fuselage. The second receiver, I ran a long extension in the back, and that's hidden up here with the 2 antennas on an angle up here. So I'm trying to get the receivers as far apart from each other as possible, and the antennas as close to 4 unique different orientations and spread out as far as possible to maximize the amount of redundancy and the ability to deal with one or more of the antennas getting blocked by something, right? So that's the idea. If you just use 2 receivers and tape them on top of each other with all 4 antennas pointed the same way, you kind of lose the benefit of doing multiple receivers and multiple antennas. Got all that set up. Got the battery set up, wired it up. I'm also doing something different that I've used Hansen. I have this Hansen Hobbies servo crimping set for making your own extensions. I've used all his stuff for years. You get the pin, he sells the pins, the housings, you can get them all different colors, crimping tools and all that. I love this stuff. He has really good quality wire. A couple of things I'm doing different. Number one, I've stopped using his crimping tool because there's actually better ones that will give you a crimp that looks closer to a real factory crimp. It doesn't mangle it up as much. There's the proper tool supposedly made by DuPont for these kind of pins. It costs like $1,000 and it's very hard to find, but you can get relatively inexpensive one. This one is a Hosan P707. It's made in Japan. This tool is about $40, but it will make a crimp that looks identical to the gold-plated factory crimped pins that you get on a Futaba Servo if you take the plugs apart, and you don't have to fight with them to get them to fit into the housings. They just snap right in perfectly, even on heavy gauge wire. So if you've never tried one, I highly recommend trying one of these. Everything else about Hansen is great. He's still my go-to place to get all the plugs and connectors because he's got all different colors and sizes and shapes and so forth. The other thing I'm trying is different wire. Instead of using Hansen heavy-duty wire, I've actually, based on what I saw a bunch of people post online, trying some of this Power Box heavy-duty wire, which is really interesting because where's the spool? I'll show you the spool. All right. Oh, I got this big spool of this stuff. Ordered a whole spool. This is like a couple 100 feet, I think, because I know I'm going to need a ton of it. So it's 3-color twisted. Honestly, we don't need twisted for RC. It's a gimmick. Use twisted in things like Ethernet cable because at gigahertz frequencies, that's the data is going in Ethernet. Twisting it will help to reject interference. But in servo leads, even though the radio is operating at 2.4 gigahertz, from the receiver downstream to your servos, the signal's still 50 hertz if you're using analog servos, or at most a few hundred hertz if you're using gyros that have high speed output for digital servos. Like on a helicopter where you've got 720 US tail servos, they can operate like 333 hertz. At those frequencies, twisting the wire does nothing for rejecting interference. So honestly, guys, sorry, but it's everything I've read in the engineering literature is it's a bit of a gimmick, but it looks cool. In every other respect, this wire is great. So it's a heavy duty wire. The conductors, it's metric, and I figure what it is in millimeters square, but the conductors work out to somewhere between 20 and 22 gauge for the power, which is red and blue instead of red and black. It's slightly smaller gauge, like more like a 24 gauge or 26 gauge for the signal, which is fine because the signal doesn't carry any current effectively, so you don't need a heavy gauge. So they do that to save a little bit of weight, but the other cool thing, and it's really hard to see on video, is the insulation. It's not vinyl, it's not PVC, it's not silicone. I think it's a plastic related to like Teflon. So it's really thin and very flexible. It's thin, it's fairly flexible. It's not like a wet noodle like silicone, so it's still somewhat easy to push things through, but it's ridiculously tough. So they say that this stuff, you barely even need to worry about protecting it from chafing, and I believe that because it takes a bit of a technique to cut the insulation with your insulation strippers because it's really hard to cut through and it's really thin. So what you end up with is this nice heavy duty wire that's as flexible and light as like the thin gauge stuff like 24 or 26, but is beefy for current carrying and for protection as the heavy stuff is. So I've been working with that. I've been making my own extensions. And again, I probably said this before, but if you have done more than a couple of builds and you're not buying like plug-and plays that have all the wiring done for you, in the long run, it's really worth investing in one of these kits with all the tools to make your own extensions because you will save so much money just buying a spool of wire and the plugs and making them yourself rather than having to order. What I spent on all this, you could probably buy hundreds and hundreds of pre-made extensions, and every single one of your extension is exactly how long you need it. It's not too long, it's not too short, you're not bundling up extra, and you don't have to wait for them to show up. You just make what you need as you go. So this weekend, I spent the weekend wiring up all the servos in the tail, the lights in the tail. You can see the 3 leads here going up the left side of the fuselage. This is the throttle servo, an extension for the ignition. There's going to be an IBAC. I'm going to put that up front, and a S-Bus 2 line for telemetry, because I'll hook up a couple of temp sensors and probably an optical RPM sensor. So I got full engine telemetry. I've done that a couple of planes, pretty cool. I did run these, and I actually spaced the ignition lead a little bit away from the other 2. Not completely necessary, because I'm going to use an IBAC, and I'm going to put the IBAC up front. So this whole line is downstream of where all the noise filtering is. But still, it's old habits die hard. I just don't want as much as possible that lead touching the others, even though, yeah, it does touch over there, and it all plugs into the same power bus. So I know the purists, the double E's will remind me that electronically it doesn't matter because it plugs in the same place. But in any case, I put the IBAC up there. What you don't want to do is put the IBAC here and then run the ignition power lead all the way up front, because that lead the lead from the IBAC to the ignition has all that RF that's going to cause you nasty interference. The lead from the battery to the IBAC doesn't. So I ran that up. That's all set. And then what else can I tell you about? So all that's set up. The wires are run. The next thing is, I also installed the wing tubes. This has all been buttoned up. That's ready to go. I need to start working on the elevators, and there's a design change because Badan did not design it with counterbalanced elevators, even though real Carbon Cub does. So I'm going to cut those and change that. We'll fix that. Probably showed this last time, but again, here's the rudder installed with Robart hinge points in little wooden hard point blocks. I'm going to do the same thing on the elevators. These are the lights for the Unilight system. Here's a light in the tail. I just set it up so that I could plug it in, and there's little slots, so you can. It should be fairly self-explanatory. You can see where the cable just slides through there, so I can disconnect that, right? So I'll be able to unplug that, pull this pin out of the hinges, and remove the rudder for transport, but still plug it in pretty easily. I'm hoping that over time, since I wrapped that cable, we're not going to have too many issues with chafing, but I'm going to have to keep an eye on that. I couldn't really think of a better way to do it than that. What else? These leads. I should build a little platform and just Velcro down these 2 caps, because otherwise, as it's flying, these are going to fly around. And over time, what'll happen is these will flop around, especially if like you're doing high G maneuvers. It's a Cub, you're not going to do too much of that, but there'll be some, and they'll pull on and stress the joints, the connections here. So I'll just strap those down so we don't have any stress relief. Basically, anywhere where there could be some chafing, especially in areas where it's going to be buttoned up and I won't be able to see it, I try to do some chafing protection and stress release and get everything strapped down. So we're moving along. We're definitely moving along. Next up is to finish the sheeting up in the nose, start building the scale doors, finish up some of this wiring, build the elevators, and then I can start building the wings and think about getting the landing gear mounted. Still have to source some wheels. I know Badan is working on making new ones out of foam. I know Extreme Flight is looking into getting big tires for their T-Cubs. So I've talked to Ben Fisher. Still waiting to hear if that's going to be an option. So if anybody else has got some options, let me know in the commentary, because I'm still thinking about that. And I'm hoping by the spring we'll be ready to start covering this and putting it all together, because as always, it's not the only thing going on. Those of you who have seen my other videos still have the camel, which I haven't looked at in a while, but we're still working on that too. So there's always something. So that's it. That's the update. Making some progress, and maybe the next time we post a video, we'll see it up on its wheels. Maybe not. Depends on how busy I get, especially in the fall. So thanks for watching, guys. Appreciate all the comments, and I'll see you next time.